Alright guys, so here's the thing. Of course, I'm not here, and I know you guys have 2 hours to be in this room, or an hour and a half, and you're probably thinking, you could probably leave, nobody would know. But remember that it's not about that. It's about getting your education. Do not leave this room until it is time. Okay? Okay, good. Now, I will ask Lena to pause the video before each slide, so that way you can finish writing whatever you need to. If you miss something that I say, just go back. It's YouTube. It's possible to do that. Alzar, write fast. Okay? If Alzar isn't there, then make sure that he gets the notes. And Alzar, just please write faster than you normally do. Okay, so geometry and trig. That is our unit. It's going to continue being our unit until we take a test. Our objective: determine horizontal and vertical lines and points of intersections. Okay, hopefully you brought your calculators because you will need them. Okay, so vertical lines. Vertical lines, of course, go up and down, and they are parallel to the y-axis. Remember when we did the slopes with our bodies? And which one would be parallel to the y-axis? So remember you had positive, negative, 0, and undefined. Undefined was the one where we clapped our hands together and we stood like straight, right? That one would be parallel to the y-axis. So when we are parallel to the y-axis, our slope, our gradient is going to be undefined. Undefined just means that you're trying to have 0 divided by some number, okay? Or not, sorry, other way around. When you have a number and it's divided by 0, okay? Whenever you have this, whenever 0's on the bottom, it's undefined because there's no number that I can multiply by 0 and get anything other than 0, okay? So, undefined gradients is when we have vertical lines, okay? Now, horizontal lines. Horizontal lines go from one side to the other side, right? They just go straight across. When you have lines that go straight across side to side, that means that it's parallel to the x-axis. When we were doing the things with our bodies and like making them positive, negative, undefined, and 0, which one would have been parallel to the y-axis? Which one would have been horizontal? The one where we put our hands straight across, right, and made a T. What slope was that? That was when it was 0, right? So when you have a slope of 0, that means that your line is going to be horizontal. Okay? Lena, if you need to pause, go ahead and do that now. Okay, so vertical lines. If I'm looking at these vertical lines, my graph is kind of like tilted weirdly. Okay, so if I'm looking at these vertical lines, I have line L1, L1, and L2, right? Let's look at L1. So L1 has the points A, B, and C. So what is the point A? Well, if I'm looking at it, I go to the x value, -3. The y value is 2. So, -3, 2. And then if I look at B, that point is going to be -3, 1. And then point C is going to be -3, -2. So, do you see a pattern in line 1? I do. All of the x's are -3, right? Let's look at line 2. If I wanted to know D, E, and F, I'm going to give you 30 seconds. I want you to find out what D, E, and F are. Go ahead. This is weird. I'm just sitting here. Do you really need 30 seconds? Can we do 20? I'm kind of getting bored. Okay, we're going to do 25 seconds. Okay, so D is 2, 3. E is 2, 1. And F, point F, is going to be 2, -3. What can you say about line 2? All of the x's are 2, right? Now, if I wanted to make an equation of a line for this, okay, I wouldn't care about what the y values were, right? It makes no difference what the y value is because the x value will always be -3 for line 1, right? So if I'm looking at line 1, it doesn't matter what the y value is. The x value is always -3. So what I would say is that the equation of a line for this problem is going to be x equals -3. Okay? Because it doesn't matter what y value is. It can be any value. It doesn't matter. But x is always going to be -3. All right? Now, if I were looking at line 2, does it matter what y is? No, y can be, y can be any of these numbers, right? It just matters what x is. What is the x value going to be? X is going to be 2. So it's weird, right? We've learned that the equation of a line is y equals mx plus c, right? We've learned this. It's like innate. But now we have x equals -3, and that's supposed to be an equation of a line, but it is when you have a horizontal line. Or I'm sorry, when you have a vertical line, okay? So whenever you have a vertical line, that means that your equation of a line should be x equals, and then whatever the x value is, right? So if I gave you the point for -5, and I said, what is the horizontal line that I keep saying horizontal. What is the vertical line that goes through this point? You would say it's x equals 4. Because that's the x value, right? So if you are looking at finding what the vertical line is for the point 4, -5, you would say that it is x equals 4. Okay? And if you're given the graph of the line, you just look at what the x value is for each of those points. Okay? So we've gone over vertical lines. Let's go over horizontal lines. Lena, if anyone is still writing, go ahead and pause now. Okay, so horizontal lines. We're going to do the same thing that we did before, and we're going to look at the points of L1, and we're going to look at the points of L2. So L1, I have A, B, and C. If I'm looking at A, the point is going to be negative 2, 2. If I'm looking at the point B, it's going to be it's going to be 0, 2. And the point C is going to be 2, 2. Right? So, if I'm looking at this, I notice that all of the y values are 2. Okay? Let's look at line 2. And I'm going to look at the points D, E, and F. Now, if I label point D, it's going to be negative 1, negative 2. E is going to be 0, negative 2. And then F is going to be 3, negative 2. Okay, so notice that the y's on line 2 are negative 2. Okay, so if I wanted to make an equation of a line that is horizontal, I would say y equals, and for line 1, it's going to be y equals 2, right? Because it doesn't matter what these x values are, right? I don't care what they are. As long as y equals 2, then that's all that matters, right? As long as y equals 2, then all of these points, doesn't matter what the x value is. Okay? Same thing with line 2. All of the points are going to have a y value of negative 2. So that means y equals negative 2 is going to be our equation of a line for this problem. And that kind of makes sense, right? So if I'm looking at the equation of a line, the point at which it crosses the y-axis is our c, and then the slope is 0, so that means that 0 times x is just 0. So you should have y equals, and then whatever point it crosses the x-axis, which in line 1, it's 2. Line 2, it's negative 2. Okay? So, vertical lines are x equals some number. Horizontal lines are y equals some number. It's a little counterintuitive, right? Because you're saying that horizontal lines are parallel to the x-axis, but their equations are y equals, right? It seems a little weird. But just keep in mind that all of the points on this line are going to have the same y value. Doesn't matter what the x value is. Okay? Lena, we're about to go on to the next one, so if anyone's still writing, please pause now. Okay, so these are all of the same questions, like asking about vertical, then horizontal, and we're given a different point for between the first two and the second two. Okay, so you don't have to rewrite the question each time. You can just say, I don't know how you want to do it, but you don't have to rewrite the whole thing. Okay, so what is the equation of a vertical line? So one that's horizontal to the y, or one that is parallel to the y-axis, passing through the point 1, negative 3. And when I'm talking about vertical lines, remember that I'm going to say x equals, right? Well, what does x equal in this point? It equals 1. So I don't care about the y value. I only care about the x value. So x equals 1 is the equation of a vertical line that passes through the point 1, negative 3. Now, if I wanted to find the horizontal line that passes through the point 1, negative 3, then I'm going to be looking at the y value, right? Because on the graph, I'm looking at horizontal lines. That means that I care about what the y value is, because all of these points are going to have the same y value. So I'm going to say y equals negative 3. That is the equation of the line that is horizontal and passes through the point 1, negative 3. Okay, let's try another one. What is the equation of a vertical line that passes through the point 4, negative 2? Well, again, vertical lines are going to look like this, right? And all of the points on here are going to have the same what value? The same x value, right? So I only care about what x is, and in this problem, x is 4. So x equals 4 is the equation of the vertical line that passes through the point 4, negative 2. All right? If I was looking for the equation of the horizontal line that passes through the point 4, negative 2, I would be looking at all of the y values, right? Because all of the y values are going to be the ones that doesn't change, okay? So I'd have y equals negative 2. Y equals negative 2 is the number, or is the equation of the line that is horizontal that passes through the point 4, negative 2. Lena, about to go on to the next one. Go ahead and pause, please. Okay, now intersections. Intersections of two lines will only intersect at one point, xy. Okay? This only happens if they don't have the same gradient. Because if they have the same gradient, what happens? Then they're parallel, right? If their gradients are equal, then you have two lines that would be parallel. They would never touch. And of course, I didn't use a straight edge, so it's not perfect. But if they have the same gradient, then they'll be parallel and they won't ever intersect. Okay? Another thing is that you also have to make sure that L1 and L2, so the lines, aren't exactly the same line, right? If you give me two equations and they're the exact same line, then of course you're not going to have any intersections. But they're also not parallel. It's called coincident, okay? It means that they're the same line. Okay? So, when L1 and L2 intersect, they intersect at some point xy. This point xy is a solution to both L1 and L2, meaning the equation of their line, right? So if I have some equation of a line y equals mx plus c for L1, right? When I plug in the point A into this equation, it's a true statement, right? And so there's problems where if it were this point right here, and this point, let's call it B, and I plugged it into the equation for L1, it wouldn't work. So, again, I'll repeat myself. So, any point on L1, right? Any point on L1, if I plug it into its equation, it will work. It will be a true statement. But if I plug in a point that isn't on L1, then it's not a true statement, right? And it means that that point is not on the line L1, okay? So, the point A at which both lines intersect, that will work in both equations L1 and L2. Okay? I will show you what I'm talking about on the next slide. But go ahead and finish writing. Lena, go ahead and pause it now. Okay, so here's an example, okay? Or two examples. We're going to do the A first. Okay? So, I have negative x minus y plus 4 equals 0, and 2x minus y plus 1 equals 0. These are two equations, and I want to find the point at which they intersect. Okay? So, I could graph them, and hopefully I do it perfectly so I know exactly the point at which they intersect. Or I can do it algebraically. Okay? In order to do it algebraically, right now they're in general form. I'm going to place them into gradient intercept form, which is the y equals mx plus c. Okay? So I'm going to take each of these equations and put them into this form, the gradient intercept form. So negative x minus y plus 4 equals 0. All I'm going to do is move the y because it seems easiest. So I'm going to add y to both sides of my equal sign. Okay, and I get negative x plus 4 equals y. Alright, so I've gotten that done. Now I'm going to do the second equation. So I have 2x minus y plus 1 equals 0. Again, I'm going to solve for y because that's the form that I wanted it. So, in order to do that, I'm just going to add y on both sides because that seems like the easiest solution. So then I get 2x plus 1 equals y. Now, I have two equations that both equal y, right? So, if I have two things that equal the same thing, then I should be able to say that this and this are equal to each other. So, I say negative x plus 4 is equal to 2x plus 1. Okay? So, I solved for y. Now that I have that, I'm going to set them equal to each other and solve. Now, in order to solve this type of problem, I have to get the x's to one side. So, I'm going to add x to both sides. And then I have 4 equals 3x plus 1. And I want to get x by itself because I can solve for it, right? So I'm just going to rewrite this over here. Okay, I'm just rewriting it over here. Now, I'm going to subtract 1 on both sides. I get 3 equals 3x. And now I'm going to divide on both sides my 3. And so I have x equals 1. Okay? So, I've found one of my values of the point A. Right? So the point at which both of these intersect, the x is going to be 1. Now I just need to find the y. Okay? Now, it does not matter which equation I use. I can use the first or the second. Doesn't matter. But what I'm going to do is, I'm going to take x equals 1 and put it into one of the equations and solve for y. Okay, so in order to create some room, because I'm kind of running out of space, I'm just going to make this smaller. Okay, so I'm going to recap what we just did, right? So we took both of these equations and we solved them for y, right? We put them in the y equals mx plus c form. And when we did that, we had two things that equaled y, right? Well, because they both equal y, I can set them equal to each other. And when I did that, that meant that I could solve for x. That's one point, that's the x value of the point at which they intersect. Okay, because we want to know where they equal each other. Okay, so now I'm going to take x equals 1 and I'm going to put it into one of the equations. It doesn't matter which one. Okay, so I have negative 1 plus 4 equals y. Negative 1 plus 4 equals 3. So y equals 3. That means that the point at which they intersect is 1, 3. Okay? 1, 3 is the point where both of these equations, oh, that was ugly, is the point where both of these equations intersect. Okay? Okay. Let's do another one. All right. So, I have two equations. The first step I'm going to take is I'm going to solve for y on both of them. So I have 2x plus y minus 3 equals 0. Y is positive, so I'm going to leave it alone and just move everything else over. So if I add 3 to both sides, I get 2x plus y equals 3. And then I can subtract 2x on both sides. And I get y equals negative 2x plus 3. Okay? So, I've done one equation, now I need to do the other. So I have 4x plus 2y plus 2 equals 0. I'm going to solve for y. So I'm going to subtract 2 on both sides of my equal sign, and I get 4x plus 2y equals negative 2. I'm going to subtract 4x on both sides of my equal sign. I get 2y equals negative 4x minus 2. And then I'm going to divide both sides by 2 in order to get y by itself. And I get y equals, and I can separate these and say negative 4x divided by 2 and minus 2 divided by 2, which gives us y equals negative 2x minus 1. Well, now let's look at these two equations. So I have this one and this one. What can I say about these lines? Well, they both have the same gradient, right? Well, what do I know about gradients that are the same? That means that they're parallel, right? Are these two lines ever going to intersect? No, they're not. These two lines will never intersect. So there's no point in it, right? It's done. I don't need to continue on because there will never be a solution to this problem. Okay? So, Lena, if anyone's still writing, go ahead and pause now. All right. So this is the point where your calculators come in handy, right? These you don't have to do by hand. And I will tell you till I am blue in the face. You can use your calculator on all parts of your test, but if you're not best friends with your calculator, it doesn't make any difference. You need to be able to use your calculator. You need to be one with the calculator in order to use it efficiently. Okay? So, if you have your calculator, you should go to page 470 and go through example 1 and use A as the example that you do, right? So instead of putting in what it says, put in what it says for A. Of course, you'll have to put it in the y equals mx plus b form, okay? Or, sorry, y equals mx plus c form, okay? In order for it to work. Now, if you don't have your calculator, that means you have to do it by hand. And that sucks for you, right? But what you're going to do for the rest of the period is you're going to go to page 102 and you're going to do 3G. Do not leave this building without putting that in my box. You have more than enough time to go through and do this problem or this problem set, okay? Do not leave the building until it is done. Do not leave this classroom until it is done. It needs to be in my box. Okay? You can go ahead and turn this off after I say this. I will see you tomorrow morning. Do not be late. Okay? All right. Bye, you guys. Have a wonderful day. Enjoy your evening. And do the work.